Okay, we need another concept to we need to define another concept before being able to properly do principle of angular impulse and momentum. And that is moment of a force. You have seen this before in statics. So I'm just quickly going to recap what it was. You have a force in 3D space. Again, moment of anything relative to a reference point is a cross product of the position vector by that force. It is very well established. We use letter M, moment about O. It's a vector. Is R cross F. Essentially same as angular momentum. It is the rotational effect of the force around that point O, and it is a vector perpendicular to both of them, and that is M. Moment has, or sometimes in a scalar form, it is called torque, or simply moment. What do you want to say? Oh, it has the unit of Newton meters. Let me write it down. Unit is Newton meters. And the direction of it is defined by the right-hand rule, perpendicular to both R and F. And one other thing, if you have a bunch of forces, well, let me write it this. If you have a whole bunch of forces, total moment of a whole bunch of forces is R cross the net force, or you can calculate individual moments, or I cross Fi. This is Fi. And or it can also be written as moment of this moment of individual forces. So you can either find the net force, then find the moment of that, or find individual moments and then add them together vectorially. But note that these are all vectors, so pay attention to their directions. One other thing here, because I'm looking at single particles, I assume all forces pass through the same point. So all these RIs are different. If you want to calculate moment using this equation, and your forces are acting at different locations, this one, a single R, is kind of, there is a process to calculate that equivalent R, but the point is, if your forces are at different locations, you can always do these two. Similarly, if you have a 2D, if I draw everything in 2D plane, if you have a force this way, a reference point there, you can always find the perpendicular distance to the line of action of force, and moment, the magnitude of it is Fd, and the direction is given by the right-hand rule. In this case, it is inside the page, so I'm going to do it this way. The direction using right hand rule. And one last thing, when you have a couple force, so essentially two forces parallel to each other, opposite directions, equal magnitudes, but a distance d apart, in that case, the moment of that couple is Fd, and really doesn't matter about which point you calculate it. About any point, the moment is going to be the same. This is called, let me write it here, couple forces, or a couple. Or this is also a pure torque. And again, direction of this couple is right hand rule. In this case, again, inside the page. So that is moment of a force. Now we have angular momentum, moment of a force. Let's go define the principle of angular impulse and momentum in the next video.